Ringwing plane. Imagine an aircraft with wings so unconventional they form a complete circle around the fuselage. A concept known as the Ringwing. This futuristic design, developed by Lockheed, was envisioned for commercial transport. The Lockheed Ringwing aircraft measured 52 meters in length with a wing circumference of 7.4 meters. The wing, attached to the fuselage at a low midpoint and arching back 27 degrees to connect to the tail, stood 23 meters tall. One of the design's most intriguing features was its fuel efficiency. Without conventional wingtips, the Ringwing reduced wingtip vortices and associated downwash, generating more lift. This resulted in shorter runway requirements, improved fuel economy, and reduced sensitivity to crosswinds. The aircraft could accommodate 120 passengers, making it suitable for commuter routes at lower altitudes. Supermassive Boeing Pelican. The Boeing Pelican was a conceptual design for an enormous ground effect aircraft, proposed by Boeing in the early 2000s. Envisioned as a colossal transport vehicle, the Pelican was designed to operate both in ground effect over water and at higher altitudes, like a conventional aircraft. With a wingspan of 500 feet and a length of 400 feet, it was intended to carry payloads of up to 1,400 tons, making it one of the largest aircraft concepts ever conceived. The Pelican would have harnessed ground effect, a phenomenon where aircraft experience increased lift and reduced drag when flying close to the surface, to enhance efficiency during low-altitude flights over oceans. Although the project never advanced beyond the conceptual stage, it showcased Boeing's innovative approach to addressing future heavy-lift transportation needs, particularly for military logistics and large-scale cargo operations. The Pelican remains a captivating example of aerospace engineering. Solar Impulse 2. The Solar Impulse 2 is a groundbreaking solar-powered aircraft designed to showcase renewable energy's potential in aviation. Developed by Bertrand Piccard and André Borschberg, its 72-meter wingspan is covered with over 17,000 solar cells, powering 4 electric motors. With an advanced energy storage system, it can fly both day and night without using fuel. In 2016, Solar Impulse 2 became the first solar-powered plane to complete a round-the-world flight, proving that clean energy can achieve extraordinary feats in aviation and inspiring the future of sustainable flight. 6th-generation fighter jets. 6th-generation fighter jets represent the cutting edge of aerial combat technology, pushing beyond the capabilities of their 5th-generation predecessors. These advanced aircraft are envisioned to be highly networked, equipped with artificial intelligence for autonomous decision-making, and capable of operating in contested environments with sophisticated electronic warfare systems. They are expected to feature advanced propulsion systems, potentially incorporating directed energy weapons and hypersonic capabilities, while also offering options for both manned and unmanned operations. Stealth technology will continue to be a crucial aspect, augmented by advanced sensor fusion and cyber warfare capabilities. The ultimate goal is to create a platform that dominates the battle space through a combination of speed, agility, information superiority, and advanced weaponry, ensuring air dominance for decades to come. DBA Quiet Jet. The DBA Quiet Jet was an experimental aircraft developed by the Douglas Aircraft Company in the 1960s to address noise pollution during takeoff and landing. This small twin-gen jet featured engines mounted above the wings to shield ground observers from noise. Although it demonstrated promising noise reduction capabilities, the Quiet Jet never progressed beyond the prototype stage due to limited commercial interest and scaling challenges. Despite its short-lived development, it stands as an important milestone in balancing aviation progress with environmental concerns. Russian Mi-32. In the 1970s, the USSR began shifting its fuel, energy, and raw material base to Siberia, the far north, and the far east, regions characterized by extreme distances, harsh climates, and limited infrastructure. While helicopters like the Mi-6 and Mi-10K were vital for transporting heavy equipment, their payload capacities often fell short. In response, the Mil Design Bureau, in collaboration with SAGI, explored the concept of a super heavy helicopter, leading to the development of the Mi-32. Designed as a tri-rotor helicopter using components from the Mi-26, the Mi-32 aimed to lift payloads of up to 55 tons, catering to both civilian and military needs. Despite extensive research, wind tunnel testing, and positive evaluations, the project was never realized due to technical and financial challenges, leaving the Mi-32 as a bold but unfulfilled vision in Soviet helicopter engineering. XPlane NASA is developing a piloted XPlane designed from scratch to fly faster than sound using the latest in quiet supersonic technology. Known as the Low Boom Flight Demonstrator, its mission is to prove that supersonic flight can be achieved without producing disruptive sonic booms. NASA aims to gather crucial data that could pave the way for commercial supersonic air travel over land. Currently restricted by regulations due to noise concerns, the plane's uniquely shaped fuselage and wing design generate supersonic shock waves in a way that prevents them from merging into louder sonic booms. Instead, the shock waves reach the ground as much quieter sonic thumps. By flying over selected US cities, NASA hopes to gauge public acceptance of quieter supersonic flight and influence future regulations. Skyrider X1 is the world's first amphibious flying passenger motorcycle. Recently unveiled at CES in Las Vegas, this revolutionary vehicle combines ground and air travel, operating as a street-legal electric moped with stabilizing auto-deploy wheels. When traffic becomes too much, the Skyrider X1 unfolds its forearms, activates 8 coaxial propellers, and takes to the skies. With a top flight speed of 62 mph and flight durations ranging from 25 to 40 minutes depending on battery configuration, it delivers swift and versatile personal transportation. Blending futuristic tech with practical mobility, the Skyrider X1 offers a bold step into the future of urban transport. Renault Air4. The Renault Air4 is a futuristic concept car that reimagines the classic Renault 4L for the modern era. Designed to celebrate the 60th anniversary of the 4L, the Air4 is a fully electric flying car with a drone-like design featuring 4 propellers for vertical takeoff and landing. Constructed with a lightweight carbon fiber body and sleek angular lines, the Air4 pays homage to its predecessor while embracing avant-garde technology. It symbolizes Renault's commitment to innovation and sustainability, offering a bold glimpse into the future of mobility. Gyroplane Nissus. The Gyroplane Nissus reimagines flight by offering pilots and passengers panoramic views through a fully enclosed, transparent cabin. Unlike traditional helicopters, the Nissus relies on an unpowered rotor for lift and a separate propulsion system for forward thrust, making it mechanically simpler and more fuel efficient. Its compact design and ability to operate in confined spaces made it ideal for urban mobility, emergency medical services, and reconnaissance missions. The Nissus also featured advanced avionics and lightweight composite materials, enhancing both performance and safety. Though remaining a conceptual design, the Nissus highlighted the untapped potential of auto gyros in addressing modern transportation challenges.